sometimes not good enough to just do it with one class. And the other thing is that the question that I'm going to take is sometimes very counterintuitive. So it's similar to what we did last time, but the question is something like this. I have three boxes, B1, B2, B3. And box 1 has 2 gold coins, box 2 has 2 silver coins, and box 3 has 1 gold and 1 silver coin. Is it clear? 3 boxes. Box 1 has 2 gold coins, box 2 has 2 silver coins, and box 3 has 1 gold and 1 silver. Question is, draw 1. I get a gold coin. Question, what is probability it came from box 1? Okay, so basically the game is very simple. We have 3 boxes. We have 2 coins of gold, 2 coins of silver, 2 coins of 1 coin of gold and 1 coin of silver. I picked up a box, and all the 3 boxes are equally likely, and I pick up a coin. It turned out to be a gold coin. What is the probability that it came out of box 1?
So
now, yeah.
the board is too bright, like.
Okay, should I? The problem with the brightness. Just a minute.
Sir, वो writing थोड़ा कम समझ में आ रहा था sir actually.
अच्छा, just a minute. Give me a minute. I'll stop video for a minute.
सर थोड़ा.
हाँ बोलो बोलो, मैं सुन
सर
रहा हूँ.
थोड़ा zoom भी कर देना इसको.
Zoom भी कर देंगे. ओके.
भैया क्रोम वाला हटा दीजिए, सिर्फ ब्राइटनेस ही रखिए.
एक मिनट. I drew out a coin. It turned out to be a gold coin. What is the probability? My question is probability that it came from box 3. Now, the problem is, in this case, most of the students, if they use their intuition, they get the wrong answer. होता क्या है, जब मैं अपना इंट्यूशन यूज करता हूं तो मेरा आंसर गलत आ जाता है. इंट्यूटिवली बच्चे क्या सोचते हैं कि मैंने क्या किया, एक बॉक्स उठाया, उसमें से एक कॉइन निकाला, वो कॉइन गोल्ड कॉइन है. इसका मतलब डेफिनेटली मैंने बॉक्स नंबर 2 तो पिक किया नहीं था, तो ऑब्वियसली वहां पे गोल्ड कॉइन है नहीं. अब अगर वो बॉक्स 2 था नहीं था, तो इसका मतलब या तो मेरा सिक्का बॉक्स 1 से आ रहा है या ये बॉक्स 3 से आ रहा है. Since I am not drawing it from box 2, it is either coming from box 1 or box 3, and therefore they write the probability is half, because it is either coming from box 1 or from box 3, and since both are equally likely, therefore my answer is half. ये लॉजिक कितने लोगों को लगता है कि सही है? ये बात समझ में आती कि नहीं?
Yes sir.
ये लॉजिक गलत है. इसलिए लॉजिक गलत है क्योंकि जब मैंने एक बॉक्स उठाया और उसमें से सिक्का निकाला और वो सिक्का गोल्ड कॉइन था, तो वो ये वाला बॉक्स हो, इसकी चांसेस डबल है. ये वाला बॉक्स हो, इसकी चांसेस 1 है, बिकॉज यहाँ पे 2 गोल्ड कॉइन है, यहाँ पे 1 गोल्ड कॉइन है. तो उसका जो एग्जैक्ट आंसर है वो हाफ ना होकर के 1/3 है. बट हम ये लॉजिक लगाएंगे ही नहीं, दोनों ही बात नहीं करेंगे, बिकॉज दोनों ही कंफ्यूजिंग हो सकती है. हम प्रॉब्लम को कैसे अटैक करेंगे? हम प्रॉब्लम को बेस थ्योरम से अटैक करेंगे, बिकॉज ये बेस थ्योरम का प्रॉब्लम है. बेस थ्योरम क्या थी? अगर मेरे पास B1, B2, B3 तीन म्यूचुअली एक्सक्लूसिव एंड एग्जॉस्टिव इवेंट थे, if B1, B2, B3 are mutually exclusive and exhaustive, so obviously these 3 events are mutually exclusive, because इन 3 के अलावा मेरे पास कोई चौथा डब्बा नहीं जिसमें से मैं कॉइन निकाल सकूं. These are only 3 options that I have from where I can draw a point. So they are mutually exclusive and exhaustive. And Bayes' theorem says that P B3/G is equal to P B3 into P G/B3 upon sigma P Bi into P G/Bi. Is it clear?
Yes.
न्यूमरेटर में है बॉक्स नंबर 3 से गोल्ड निकालने की प्रोबेबिलिटी और डिनोमिनेटर में है बॉक्स नंबर 1 से गोल्ड निकालने की प्रोबेबिलिटी, बॉक्स नंबर 2 से गोल्ड निकालने की प्रोबेबिलिटी, बॉक्स नंबर 3 से गोल्ड निकालने की प्रोबेबिलिटी. न्यूमरेटर इज P B3 intersection G and denominator is P B1 intersection G plus P B2 intersection G plus P B3 intersection G. जैसा हम लोगों ने कल बात की थी. Okay, and now if I want to plug in numbers, this will be equal to PB3 into P G/B3 upon PB1 into P G/B1 plus PB2 into P G/B2 and plus PB3 into P G/B3. Now if I put the number PB1, PB2, PB3, they are all equally likely. So 1/3, 1/3 and 1/3. Okay? Any problem with that? Into something like that. PG/B3 is probability of drawing a gold coin from B3, which is 1 gold coin out of 2 coins. So it is half. PG/B1, probability of drawing a gold coin from box 1. It is 1. PG/B2 is probability of drawing a gold coin from box 2, which is
0.
and PG/B3 is 1/2, and therefore my answer is 1/6 upon 1/3 plus 1/6, which is 1/6 upon 1/2, which is 1/3. Okay, so this kind of a question, if you try to do it intuitively, जो आपका मन कह रहा है, तो मन दो तरीके से सोच सकता है, जिसमें से एक सही है और एक गलत है. तो मन से सोचने से क्या होता है, कई बार सही आंसर आ जाता है, कई बार गलत आंसर आ जाता है. सेम बच्चे को ये एक्सप्लेनेशन दे दो तो वो कहेगा हाँ सर आप ये कह रहे थे, और वो एक्सप्लेनेशन दे दो कहेगा हाँ सर आप ये कह रहे थे, बिकॉज देयर इज अ प्रॉब्लम विद द लॉजिक. So that is why I say don't think intuitively, apply Bayes theorem, get the answer, and it's very simple. एक basic सी theorem है, उसमें PB1, PB2, PB3 की वैल्यू चाहिए जो कि 1/3, 1/3, 1/3 है. PG/B1, G/B2, G/B3 चाहिए जो कि 1, 0 और हाफ है, और वैल्यू पुट करो और जो आंसर आता है वो आंसर. Is that correct?
Yes,
Yes, sir.
Good. अब ऐसे बहुत प्रॉब्लम कर सकते हैं, बट we'll move ahead.
सर
Yeah.
सर जो इवेंट पहचानने के लिए आपने स्टेटमेंट बताया था लास्ट
मैं
क्लास
फिर
में,
दो बात बता देता हूँ, इसने बहुत अच्छा क्वेश्चन फेस किया, मुझे दोबारा उसको रिपीट करना चाहिए था. बेस थ्योरम का हर क्वेश्चन एक ऐसे लंबे से स्टेटमेंट के साथ स्टार्ट होगा और लास्ट लाइन होगी
सर इंग्लिश में इसको जरा.
In Bayes theorem, almost all the question will start with all the information, and the last line will be something like given dash find probability of dash. So essentially, if E1, E2, E3 are my mutually exclusive events and A is some other event, so I am asking what is probability of EI given A. तो ये जो स्टेटमेंट है जो गिवन के साथ लिखा हुआ है वो मेरा A है. The statement which is given, that event is event A and find probability of dash, this is one of E1, E2 or E3. So this way we will identify what is A and what is E1, E2 and E3. Then my next step is I have to find PE1, PE2, PE3. इस क्वेश्चन में था given that coin drawn is gold, find probability that it came from box 3. So my given is gold and one of the events is B3. Clearly मुझे पता लग गया कि मेरे E1, E2, E3 कौन से हैं? Box 1, box 2, box 3, and I gave them probability 1 by 3, 1 by 3, 1 by 3, because in this case they were equally likely. Then the second thing that I'll need is P G slash E1, P G slash E2, or sorry, P A slash E1, P A slash E2, and P A slash E3. Conditional probabilities which turned out to be 1, 0, and half in the previous example, and then I'll just apply the base theorem, put all the numbers, and I'll get the answer. Okay.
Yes.
Yes, sir.
Good. So, next thing that I want to teach is about independent events. So, in the last class, I told you P A slash B is equal to P A intersection B upon PB. Okay, that was the condition of, that was the probability of A given B has happened. Is it clear?
Yes, sir.
Now, if A and B are independent events, then PA slash B should be equal to PA. Let's look at it. Suppose A is probability that it will rain today in Delhi, and B is probability that I will wear blue t-shirt. Now clearly we know that these are independent events, because we know that probability of raining in Delhi has nothing to do with my t-shirt. Okay, so what will happen? Whether I wear a blue t-shirt or not, the probability of rain in Delhi will remain same, or I can say the probability of rain in Delhi, given that I'm wearing a blue t-shirt, is same as what was the probability of raining in Delhi. And if I use this information, I will come to a conclusion that A and B are independent if P A intersection B is equal to PA into PB. I'll take this B over here and I'll get, what is the definition of an independent event? Two events are independent if their intersection is equal to product of their probabilities. Is it clear?
Yes, sir.
Yes, sir.
Okay. So I have a question on this concept. This is one of the previous year's NEET question, and the question is something like this. They say toss 3 coins. Coin number 1, coin number 2, coin number 3. X is heads on first 2 coins. Y is tail on third coin, and Z is 2 tails in 3 tosses. Okay, these are my 3 statements, and my options is A, X and Y are dependent. B is Y and Z are dependent. C is Y and Z are independent, and D is X and Z are independent. Okay, so first thing first, without knowing anything, I'm sure that answer is either B or C. Can you tell me why? Anyone? Why answer is either B or C?
Because that's there are that's
Because either Y and Z are dependent or Y and Z are independent.
Independent, yes.
If only one answer is correct, it is either B or C. Okay, but forget about that. Let's look at these numbers. So what I'll do, I'll write Px, Py, or rather, I will do part A and then ask you guys to go for the other part. So part A is, if X and Y are dependent, it means Px into Py is not equal to Px intersection Y. Okay, independent means Px into Py is equal to Px intersection Y, and dependent means Px into Py not equal to Px intersection Y. What is Px? Anyone? In toss of 3 coins, what is the probability that I'll get head on first 2 coins?
Sir, 2 by
Anyone?
8.
Anyone?
Sir, 2 by 8. Sir,
Hanji?
2 by 8.
2 by 8. Okay? So obviously, since I'm tossing 3 coins, I have 2 outcomes on first, 2 outcome on second, 2 outcome on third. So number of sample spaces 2 into 2 into 2, 8. We can actually count them, H, T, that way. Now X is H or T. So these are the 2 cases where I can have heads on first 2 tosses. Therefore, probability of X is 2 by 8. Similarly, what is probability of Y? Tail on third coin. So it can be head, tail, head, tail, tail, head, tail, or tail, tail. Therefore, probability of Y is 4 by 8. So this is half. So this is 1 by 4. This is 1 by 2. And X intersection Y. What is intersection? Just this one set is element is common between them. So this is 1 by 8. Head on first 2 coin and tail on the third coin. That can happen in only one way. H, T. Therefore, what is the probability of intersection? 1 by 8. Now, half into 1 by 4 is equal to 1 by 8. Therefore, they are independent, which means this is a wrong answer. Is it okay?
Yes, sir.
Now, we'll check for option number B. We will calculate Py, we will calculate Pz, and we will calculate Py intersection Z and check whether they are equal or not equal. So y I have already written. Py is 4 by 8, which is half. What is that? 2 tails in 3 tosses. How is it possible?
Sir, 3 by 8.
3 ways: tail, tail, head, head, tail, or head, tail, tail. Therefore, probability is 3 by 8, and y intersection z is this event is common and this event is common. Two things are common between y and z. Therefore, this number is 2 by 8. Clearly, half into 3 by 8 is not equal to 2 by 8, and therefore these events are
Dependent.
dependent. Therefore, B is the correct answer, C is incorrect, and obviously DX option D will also be incorrect. But I would like to check it for you so that we can have a small practice session. So D, PX, PZ, PX intersection Z. PX is already 2 by 8, PZ is already 3 by 8, and PX intersection Z is, I have to find intersection between this set and this set. Clearly, if there are 2 heads on first 2 coins, there is no way of getting 2 tails. Okay?
Yes, sir.
Which means this probability is 0 by 8. And clearly, 2 by 8 into 3 by 8 is not equal to 0 by 8. Therefore, X and Z are dependent. Therefore, D is incorrect. Any problem with this?
Sir, just one question, sir.
Sure.
सर आपने इनिशियली इंट्यूटिवली कैसे बता दिया था कि बी या सी में से कोई होगा?
अरे बिकॉज या तो y और z डिपेंडेंट होंगे या y और z इंडिपेंडेंट होंगे भाई। px सॉरी py into pz की वैल्यू जो भी होगी वो या तो इक्वल टू py इंटरसेक्शन z होगी या तो वो नॉट इक्वल टू py इंटरसेक्शन z होगी। तो इसका मतलब इन दोनों में से एक बात तो क्लियर होगी ही ना।
यस सर, यस सर।
और सिंस इट इज ओनली अ सिंगल ऑप्शन करेक्ट आंसर, तो ए और डी चेक करने की जरूरत ही नहीं है।
जी सर।
If you think like that, you will save few seconds in your paper, which may be helpful. Actually, they will be very helpful. Okay?
Okay, sir.
Multiple it can be possible for other options.
Just a minute. Sorry. Now, there's another thing about these dependent and independent, rather independent events that I want to share with you. And these, let's take a problem. I have 3 events, X, Y, Z, and a sample space F. So this is my universal set of sample space. I have an event X, event Y, event Z. Okay. Now what happens? X, Y, Z divide this sample space into 8 regions. This is region number 1, 2, 3, 4, 5, 6, 7, 8. What is 1? Statement 1 is P X intersection Y complement intersection Z complement. I assume everyone knows what is complement. Complement means X is happening, Y is not happening, Z is not happening. Okay? Okay? Similarly,
Yes, sir.
what is 2? It is P x intersection y intersection z complement. And 3 is p x complement intersection y intersection z complement, because region 3 is outside x, outside z, but inside y. Is it okay?
Yes, sir.
Good. And so on and so forth. Anyone? What is 5?
X, Y, Z in all intersections.
Intersection.
P x intersection y intersection z. 7 is P
Y intersection. Sorry, Z intersection. X complement, Y complement.
good, x complement intersection y complement intersection z. And obviously 8 is P x complement intersection y complement intersection z complement, which is neither in x nor in y nor in z. Okay. Now, what is the beauty of independent events is if probability of x is A, then probability of x complement is 1 minus x. Okay? Okay?
Yes, sir.
Yes. If probability of y is B, then probability of y complement is 1 minus B. And if probability of z is P, then probability of z complement is 1 minus P. So if I know these 3 numbers, I also know these 3 numbers, and therefore I can give probabilities of any of these 8 events. Okay? So
Yes, sir.
just pick up a number 1 to 8. Pick up a number.
So 3.
3. So if someone asks me what is the probability of x complement intersection y, intersection y intersection z complement, I will write 1 minus a into b into 1 minus c. Is it correct?
Yes, sir.
Okay. So the way this question will be formed will be something like this. In your class, almost 80% students like T. Almost, I think, will be close to 100% maybe, but okay, something like that. There are about 50% of students who like coffee, and maybe like 100%, 90% who like beer. Is it okay? Does it look like
Yes,
a
sir.
nice distribution?
No, sir.
No, I'll make it 20%. Okay. Non-alcoholics. Okay.
भैया आप तो परसेंटेज कम ही रखिए उसका.
हाँ, चल रहा है ना? That doesn't make any difference. So, in a class, 80% of the students like tea, 50% like coffee, and 20% like beer. Now, find probability of, give me a number. चाय पीता है, नहीं पीता है, कॉफी पीता है, नहीं पीता है, beer पीता है, नहीं पीता, something like this. How many of, what is the probability that someone does not like tea but like coffee and beer? And what will be the answer?
So 1 minus 0.8 into 0.5
Third,
into
1 minus
0.8.
0.8 is 0.2 into 0.5. I'll make it 60% because 1 minus x and x should be different number, in 2.6 and into 0.2. So I'll make it 30% so that there's no confusion. Okay, something like this. Okay, so what is happening? 20% do not like tea, 60% like coffee, and 30% like beer. Therefore, probability that a given student will like beer and coffee but not like tea will be 0.2 into 0.6 into 0.3, which will be 0.036. Okay, which is a very small number because most of the people they like tea, so वैसे ही 70% हट गए, and most of the people do not like beer, तो वहां से भी 70% गया, फिर कॉफी वाला भी लगाना है. This is a small number. But if I ask you what is the probability that someone like tea, like coffee, but does not like beer, so intuitively, obviously, in such a population, that will be a large number, and the answer will be what?
0.8 into
0.6 into 0.7.
0.6 into 0.7, which will be 42 into 8, 336, which will be 0.336. And clearly, चाय की प्रेफरेंस ज्यादा है, बियर की थोड़ी कम है, तो इन दोनों नंबरों को कंपेयर करें तो नीचे वाला नंबर बहुत बड़ा निकल गया बिकॉज चाय काफी लोग पसंद कर रहे हैं, और ऊपर वाला नंबर काफी कम हो गया बिकॉज बियर लोग नहीं पसंद कर रहे हैं. ओके, so these are the kind of questions. Just by knowing these three numbers, I can tell lot of things. What is the probability that someone like tea but does not like coffee? It will be simply 0.8 into 0.4. I'm not interested in beer, so I'm not considering it. Okay, 80% like tea and 40% does not like coffee, and therefore probability is 0.32. Okay, this
Yes,
way
sir.
we can find probability of lot of events if they are independent. I can use this logic only if it is given in the question that your preference for tea, coffee and beer are independent. If they are not independent, then obviously we can't use this logic. Okay,
Yes, sir.
good. So the next topic that I want to cover, and I'll cover this topic in detail from the next class onward. Today is just basic introductory kind of a thing, is all about probability distribution. Okay, so you know there's something called random variable, and then there's some kind of a probability that I can associate with it. Okay, so random variable, there are two types, discrete and
Yes.
continuous. Okay, so suppose I ask you what is number of hits obtained in toss of 4 coins. Okay, so if x is number of heads obtained in toss of 4 coins, then what will happen? X can either be 0 or 1 or 2 or 3 or 4. So there's no way you can have 2.5 heads in toss of 4 coins. So such random variable is called
Discrete random variable.
discrete random variable. And continuous random variable. So suppose I ask one of the students, and I ask him to throw a cricket ball, and x is distance thrown by him. Then x can be 17 meter, it can be 75 meter, it can be 37.2896 meter as well. So then there's no restriction on the value of x. It can take any continuous value. This is an example of continuous variable. Okay, clear?
So
Yes, sir.
discrete one, can you just give it?
Discrete is something which can have discrete values. I throw a die and X is the number obtained on a die. So it can be either 1 or 2 or 3 or 4 or 5 or 6.
Oh, yes, sir. Yes, sir.
There is no way I can have a throw of 1.7 on a die unless and until one of the faces is marked 1.7, which is in a different case. So where the value of X is discrete, it is not continuous.
Okay, sir.
And
Yes,
when
sir.
I'm throwing a ball, I can throw it anywhere. 17 meter, 18 meter, 18.5 meter, 18.5 to 9857 meter, anything. So that is a continuous variable. Okay. So discrete random variables, they come with probability distribution tables. So I will have list 0, 1, 2, 3, 4, and I have certain probabilities. I know in this case the probability will be something like this. We will talk about binomial distribution in the next class. So probability will be something like this: 6 by 16, 4 by 16, 1 by 16 kind of a thing. But the point is I have certain values of X and then I have certain values of probabilities for X. Okay. And here probability of X has no meaning. Why it has no meaning?
So because it's a continuous variable. So
It is a continuous. So here I will talk about probability of X lying between an interval. Okay, it can be less than equal to or less than something like that. Okay. So what will happen? I will ask you, if I ask you, I throw a cricket ball, what is the probability that it will fall at a distance of 18.5 meter? That is an absurd question. Because even if it is 18.50001, then that is not 18.5. And even if it is 18.499, it is not 18.5. So I'll ask, what is the probability that my throw lies between 17 and 18 meters? Okay. So it will not be a value, it will be a range. It will be a continuous set of values, and the probabilities will be given by some kind of a function. So I will have a probability distribution function fx, and I'll write probability that X will lie between A and B will be something like A to B fx dx ka integration. Is it clear?
Yes.
Yes, sir.
X can be discrete, X can be continuous. If X is discrete, I can have discrete values of X and I can give values of probabilities for each X. If X is continuous, then I cannot give value of probability for a specific value of X. I can give value of probability over a range of X, and that will come from some kind of function which is called probability distribution or probability density function. Now, what is going to happen from the next class onward? I'm going to talk about binomial or Bernoulli. These are Poisson. These are some of the discrete random variables. And then if I talk about Gaussian or exponential or logarithmic or something like that, then these are some kind of a continuous random variable. So how we are going to approach those problems is a different thing, because suppose I want to know what is the mean of a binomial variable. You will always know the formula for mean of the binomial distribution. So before going to there, what I want you to know, if a table like this is given, how you will find mean, how you will find variance and things like that. Okay, so we'll start picking up some problems. Okay. So first, let's pick up a problem from a discrete random variable. This is some variable X which can take a value of 0, 1, 2. Knowingly, I'm not taking large values because that will require a lot of calculation. So basically, just for the sake of example, I toss 2 coins and X is number of hits. Okay. What is my event? X is number of heads in throw of 2 coins. So obviously X can be 0, X can be 1, X can be 2. Since I can have head, tail, tail head, and tail as the 4 outcomes, therefore probability is 1 by 4, 1 by 2, and 1 by 4. Is it okay?
Yes, sir.
Now, suppose I ask you what is mean of X, which is also written as X bar, which is also written as average of X, and which is also written as expected value of X. This is given by sigma pi xi. Okay, what is the mean of X? Sigma pi
Yes, sir.
xi. So what is, if I'm tossing 2 coins again and again and again and counting number of x's, then what is number of x that I'll get on an average? It will be p1 x1 plus p2 x2 plus p3 x3, because there are only 3 values of x over here. This is 1 by 4 into 0, 1 by 2 into 1 plus 1 by 4 into 2. Okay, this is average value of x. Obviously 0 plus half is 1. दो सिक्का उछालोगे तो ऑन एन एवरेज एक बार हेड आएगा, एक बार टेल आएगा. Obviously I am assuming ये bias point नहीं है. अमिताभ बच्चन उछालते तो हर बार हेड आता, but that is a different story altogether. Okay, so for an unbiased point, average value of x will be what? 1. Is it simple?
Yes,
Yes.
sir.
Okay.
Yeah.
तुम्हारा मन है तुम ये नंबर चेंज कर दो, इसको 0.1 कर लो, इसको 0.3 कर लो, इसको 0.6 कर लो, और मेरा नंबर यहाँ पर 0.1 हो जाएगा, यहाँ पर मेरा नंबर 0.3 हो जाएगा, और यहाँ पर मेरा नंबर 0.6 हो जाएगा. And for such a coin, probability, sorry, the expected value of x will be 0 plus 0.3 plus 1.2, 1.5. Okay, so on an average I will get x is equal to 1.5, obviously because I'm getting 2 lot many times. Okay, so that is how I'm going to calculate the mean. Easy. Sigma pi xi. Okay,
Yes, sir.
this is expected value of x. Let me go ahead with something called expected value of x square. What is expected value of x square?
Sir, sigma x
Pi
square.
xi square.
Good. It is sigma pi xi square. In my case, it will be p1 x1 square plus p2 x2 square plus p3 x3 square, which will be equal to, for these numbers, 0.1 into 0 square plus 0.3 into 1 square plus 0.6 into 2 square. Okay, any problem? Instead of multiplying x with pi, I am multiplying x square with pi, and the value is 0 plus 0.3 plus 2.4, 2.7. Any problem?
No, sir.
No, sir.
Now I will write variance of x. You know, variance is square of standard deviation is expected value of x square minus expected of a value of x whole square. I'll write once again, don't worry about that. What is the definition of variance? I have to write expected value of x square, which is 2.7 minus square of expected value of x, which is minus mean square. And what I'll get? I'll get something like 2.7 minus 2.25, which will be how much?
0.45.
0.45. This is my variance, and my standard deviation, sorry, I'm just getting out of space, will be under root of 0.5. Okay. So now let me write it over here on the top. For a discrete random variable, expected value of x is sigma pi xi. Expected value of x square is sigma pi xi square, and variance of x is equal to expected value of x square minus mean square of the mean. Okay. Okay.
Yes, sir.
Yes, sir.
Good. They're almost running out of time. एक छोटा सा प्रॉब्लम कर लेते हैं. मैंने इस बार x की वैल्यू ले ली 1, 2, 3, 4, 5, 6 और प्रोबेबिलिटी ऑफ x ले ली 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. मैंने क्या किया?
अपने इवेंट्स की प्रोबेबिलिटी बता दी.
I rolled a dice. पासा फेंका. So x is the outcome on the dice, which can be 1 to 6, and if it is a fair die, then what is the probability of each x? It is equal to 1/6, 1/6, 1/6. Okay. Please tell me expected value of x, which is basically mean of this variable, expected value of x square, then variance of x, and then standard deviation of x. Please go ahead, take your time and let me know.
So expected value 7/2.
Expected value 7/2. ठीक है. For those, it is 1/6 into 1 plus 1/6 into 2 up to 1/6 into 6. If I take 1/6 common, this is 1 plus 2 up to 6, which is 1/6 into 6 into 7/2. So therefore it is 7/2. Okay. Is it okay?
Yes, sir.
Yes, sir.
Natural number is n plus 1/2. Obviously 1 से 6 तक तो मैं ऐड भी कर सकता हूँ. It will be 42 by 2, 21, but ऐड नहीं भी करे तो 7/2. Okay. अब expected value of x square क्या हो जाएगी? 1/6 into 1 square, 1/6 into 2 square, up to 1/6 into 6 square. ये हो जाएगा 1/6 कॉमन ले लें. 1 square plus 2 square up to 6 square. अब मुझे पता नहीं कि इसको ये फॉर्मूला याद है कि नहीं. 1 से लेकर के n तक जब मैं स्क्वायर्स को ऐड करता हूं तो
n into n plus 1 into 2n plus 1 by 6.
Therefore this number is 1/6 into 6 into 7 into 13/6. एक 6 से 6 कैंसिल हो गया. 13 into 7 is
91/6.
91/6. Okay, so this is 91/6, and then variance will be equal to 91/6 expected value of x square minus 7/2 whole square, which is 49/4. So 91/6 is, okay, I'll just take an LCM of 12. 91 into 2 is 182, and 49 into 3 is 147, and this will be 35/12. This is variance of x, and therefore standard deviation is under root of 13/12. Okay. Is it
Yes,
fine?
sir. Yes, sir.
Yes, sir.
Good. since most of the questions are about continuous, sorry, about discrete random variable, so I'm not very much worried about continuous one, but if I have to write it, expected value of x will be integral x fx dx from minus infinity to infinity. Okay, whatever possible values of x are possible, I simply multiply x to fx and I'll get, or maybe from whatever lower limit to, from whatever a to b. If x is defined between a and b, then I'll integrate from a to b x into fx dx. That will be our expected value of x. Expected value of x square will be a to b x square fx dx, and then variance of x will be simply expected value of x square minus expected value of x whole square, and sigma will be root of sigma square. Okay.
Yes, sir.
We are
Second
not
one
doing
will
any
be-
problem on this as of now, because I don't think that is important. Discrete random variables are more important. So we will first of all go through the discrete random variable. When I'll come to the continuous random variable.
Second one will be x square fx dx, right?
Yeah, sorry for the mistake. It's x square fx dx. So since I want to do it one by one, so I'm not doing any problem about a continuous random variable right now. We will go through the discrete one first, and when I'll come to the continuous random variable, we will try some problem on this as well. Okay.
Yes, sir.
Okay. So that's it from me today. Thank you very much.
Thank you, sir.
Thank you, sir. Good
Thank you,
night.
sir.
Thank you, sir.
So,
Night.
Thank you, sir.
You're welcome.